In this video, we're going to graph some polynomial functions given specific characteristics. However, not all characteristics can be combined to create a polynomial. So if we cannot graph something, we have to explain why we can't graph it. All right, so there's a few examples here. We're going to jump right into problem number 1. So characteristics given. We have a degree 4 function, okay? It has an a value less than 0. So normally a degree 4 function would look something like our U-shaped graph. All right, that's an even degree function. However, when it says the a value is less than 0, that means it's negative. And if it's negative, that means we're going to have our little U shape here kind of become facing down. Okay? We have a relative maximum at x is equal to -4 and absolute maximum at x is equal to +3. So maximum means that we're at the highest points, all right? And basically if our graph is concave down like this, that would make sense. Relative maximum x is -4. So if I look at my graph here, at -4, I'm going to pick a maximum point and say, I'm going to say it goes up to 2. All right. But then it says it has an absolute maximum at x is equal to 3. So at +3, I need to make sure that this is the highest my graph ever gets to. Okay. So my graph could look something like, let me make sure I'm not missing anything. Nope, I am not. All right, concave down. It's going to cross the x-axis once, cross twice, 3 more times, and there we go. Okay, whoops, hold on a second. Let me take that curve back out. I screwed up something. Okay, so this point, what I screwed up was I have to make this a maximum so that it has to go through this point, but it's going to immediately bounce back down. So let me try that again. So let's do that, then that. There we go. Okay, sorry about that. So this point is where our graph goes from being increasing to decreasing. This point, it does the same thing, but this is the absolute highest point we ever get to, so that's why it's called the absolute maximum. 4th degree, 1, 2, 3, 4, and this is definitely an a value of negative something. All right, so that one we absolutely could sketch. Let's move on down to problem number 2. All right, our graph is always increasing, which means from left to right, this graph needs to continuously go up. Now, it doesn't have to go up the same amount all the time, but it has to always be increasing. Y-intercept at 5, so let's go up to 5 here and mark a y-intercept. X-intercept at -3, 1, 2, -3 is right here. Yeah, we can absolutely draw this graph. The very simple way that you could do this is literally just play connect the dots and draw a linear function. A linear function of this form, that is an always increasing graph. It has the the y-intercept and the x-intercept we were given. So sure, that would absolutely be a graph for problem number 2. Are there other ways to graph it? Sure. If I take out that line that I just drew, I could draw something like this, which almost looks more like your cubic or your odd degree functions. Yes, there's a little change here in how fast your graph is increasing, but it's always increasing. So yeah, there's a couple different ways to draw those. All right, let's slide on down to problem number 3 here. Okay. Characteristics, odd degree function. So remember, that's one we kind of just drew. Okay, so that is an increasing function there. Okay, increases to x equals -3, then decreases to x equals 3, then increases. Okay. Oops, we got a problem here. Okay, absolute maximum at y is equal to 4. That's not possible with an odd degree function. An odd degree function is going to go from -infinity to infinity at some point. And so you can't have an absolute maximum. You also don't have an absolute minimum. All right. So this graph cannot be sketched. All right. And the reason I'm going to tell you is odd degree functions do not have absolute, and I'm not going to use the maximum or minimum. I'm just going to use the term extrema. Okay. So extrema would cover either an absolute maximum or an absolute minimum. So odd degree functions do not have absolute extrema. And that's it. You just can't draw that graph then. Okay. Let's take a look at number 4 here, and this will be the last one for this video. There are a few more problems. I'll go ahead and make a separate video for those. So we're given the end behavior. So as x goes to infinity, f of x goes to infinity. So over here on the right side of my graph, what I eventually will be trying to draw is something that goes up to infinity. All right. Now, obviously, there's more to the graph, and we'll figure that out. We have the other half of the end behavior. As x goes to negative infinity, f of x goes to positive infinity. So on the left side of our graph here, right, this is going to negative infinity. Our function is increasing. All right, it's going up to positive infinity. For x-intercepts, okay, so I'm going to have to cross the x-axis 4 times, and a relative maximum at y is equal to 3. Now, one thing you might want to do is just give yourself a little notation here. This is y is equal to 3 right here. Okay, you can mark this graph up any way you want to. So let's see, if I take my curve and I come down, there's going to cross the y-axis once, twice, there's my relative maximum at 3, my third x-intercept, fourth x-intercept, and there's my function. All right, so a relative maximum means you're going to hit a transition point here. It's going to go from increasing to decreasing at that whatever value we say. Infinity and infinity for our end behavior, 1, 2, 3, 4 x-intercepts. Sure enough, we can graph that one. So I'm going to go ahead and close this video out for the first part of these problems. I'll make a second video, like I said, for the next 3 questions and see if we can graph those. If you have any questions or concerns about this characteristics and why we can or can't graph